Okay, guys, so what I'm going to do with you today is we're going to look at some post-processing. So what I'm working from here is a case and data file that I wrote from my high performance computing uh, simulation. So I exported a case file of what we just seen there previously, and I ran it. And you can see here just some of the output from the computer, just using the cores and all the iterations. And I have my drag report and lift all printed out there. So I have these case and data files. So what you can do is if you just want to do some simple post processing, you can just read in the data file into Fluent. You can come down here, or sorry, so you just boot this up here. So what you can do is you can load in your case file if you're starting from complete scratch, and then you can load in your data file after that. So I'm going to load this in with maybe seven processes, double precision, as we said before, and just set a reasonable working directory for that. And yeah, so that's what I've done down here. It just takes a while for it to load in. So you can see that I done that simulation on 80 cores, and it repartitions that onto the 7 cores that I've assigned it. So that just took a while to load in there because that is quite a few million cells. And so when you're dealing with something of that size, it'll take a little while to load in. So as you can see there, that's what we're dealing with. Okay. So let's have a look at some post-processing techniques and the main ones that you'll want to be using. So when you read in your data file, you can read in your case first and then come up here and read in your data file. You will have your options down here for results, and so you can create stuff down here. So some of the most interesting ones you'll want to create is a Y plus contour to make sure that you have got the correct Y plus for your simulation, that it's kind of valid. So go down to turbulence and down to Y plus. Okay, and then you want to select your wall and then deselect the ground because we don't want to see the Y plus in the ground. And then turn off global range there. That should be good. Okay, so let's give a look at this. Should take a second. I don't think this is going to take too long now. Usually doesn't. So we give it a second. Okay, I'll pause that. I don't expect it to take too long. No, so that took maybe what 30 seconds, and this is what I'm looking at here for a Y plus contour. So you can see there, the Y plus there is kind of blue, a little bit of green in some places, so it is between 1 and 5 relatively. And another cool thing you can do here is say turn off auto range and put your range in here. So say I don't want it to go above 5. I just want to see everywhere that it's 5. So you'll see what this looks like when I save and display it. So just let that load there again. We'll give that a pause. Might take 20 seconds. Okay, so that actually only took, maybe 10 seconds. So what's this showing me here? So this is showing me everywhere that I see a bit of color, that means I'm meeting that Y plus of 5 or less. And you can see there's some areas that are kind of blacked out, so they're just above 5. And so that's only in a very small number of regions where the flow is very quick. See around the wheels there. So I'm kind of okay with that. So if I change that maybe to 6, I'd see that they get colored in. Something I will do is come down here to color map, change that to float, and that'll fix up the contour plot there. So I'll actually just shoot this up to 6 and save and display that. Might only take a second. Yeah, so you can see there, it's basically everything's colored in now. So that just kind of shows that I have the correct Y plus. And anywhere where there's stagnation, you're gonna have a very low Y plus, and anywhere there's fast moving flow, the Y plus gets higher. So you can see the Y plus at the stagnation and wake regions at the rear there. You can see that the Y plus is very low. Okay, so that's Y plus, very important contour plot. So yeah, that's one of them. Another one that you'll find really interesting is plotting along the symmetry plane. So I come down here, we get so let me change my plane here. So turn off the walls and turn on the symmetry plane there. And turn off global range, put on auto range there. Static pressure. Yeah, we might go for pressure coefficient I'll plot. Okay, so save and display that. Let's have a look at this. So hopefully this doesn't take too long. So same again. I'll just give these a pause after every time I click on these. They're not taking long, but it just makes the video more efficient if I just click pause. Okie doke, that's loaded in there. It took a few seconds. So if I look in from the side here, I can see the pressure coefficient. And so that gives me a lot of information on where I have high pressure regions and where I have low pressure zones. So as you can see there, CP of 1 there at the stagnation, and it changes as it goes out. Another really interesting one as well for pressure is the total pressure. Okay, so let me plot this, and I'll show you how to put the mesh in with this in a second. So I'll just plot that there. And that didn't take long. So this is kind of showing me here is, places where there's pressure loss. Okay, so kind of like an energy loss sort of thing. Um, so you can see there in the recirculation regions there in the wake, there's pressure loss, and it's just kind of interesting to see like over the top of the trailer there. That's quite good. That picks up a lot of keeps the flow well attached, and we'll see that as well from a velocity diagram. These are very important too, so I might just go for a velocity magnitude along that symmetry plane. So you get a lot of information from plotting stuff along this symmetry plane. So that's a huge amount of information there. I can see that the flow is pretty well attached over my van. Moves very quickly over there. Stays kind of attached under the van, and it's not doing the worst. So you can see it kind of reattaches a little bit here maybe. Goes very quickly through there, and you can see what the wake region looks like there quite nicely. Okay, so that's, as you can see, there's a lot of information from that. So what you can also do is you can plot the mesh. So I can click draw mesh here on faces. So I'll turn off the inlets, just the wheels. Don't want the ground. Cool. So I click display on that, and if I want them all to have the same color, I say color by type. I think will do it for me. Yeah. And then I'll display this pressure thing again, and then I'll have the mesh here. So that's just kind of if you're interested in how to do that. And so I could also have like a pressure contour plot on that as well. Show you how to do that. So that's another interesting type. So definitely plotting along that symmetry plane is you get pick up a lot of information. Another type of plane that you'll want to do is, well, a contour plot. Let's do a contour plot for something called wall shear stress. So wall fluxes, and we look at the wall shear stress um, along our vehicle, and we'll see what we can deduce from that. So do I want auto range? Yeah, sure. We'll turn on auto range, see what it looks like. Give that a draw. So I'll pause this. Okay, so you can see the results from that. So everything seems dark blue. So my range isn't very good. So maybe if I can bring that down, maybe between 0 and 3. Let's see what this gives me. Okay, so this is giving me more information now, right? So this is kind of showing me dark blue would signify that the flow isn't really that attached to the vehicle. So I can see along there as the wheel is spinning, the flow kind of detaches here, and it usually does detach, comes over that, and I find it very difficult to stay attached early on, but then it might reattach as it moves down further. But usually along there, it's quite typical that you'll see the flow not attached. Um, Obviously there at the front it stagnates. It's finding it very hard to, we'll say, move along in the same way that it's moving up here. So it might impact and like get pushed around, but it won't be moving very quickly there. So think about what's in the wall shear stress in the formula and the gradients. So where else that you can pick up some other interesting information. So if you have like an aerodynamic feature here, so like I have quite a bit going on the roof of this here, so you can see the flow seems to be having a bit of difficulty moving over this patch here. So I could probably redesign this edge here so that it smooths a little bit better and it catches the flow a little bit more there. But the back here, this side panel looks very good. But I'm kind of losing the flow a little bit here, so I could probably change the shape on that maybe to increase the performance of that. And you can see the stagnation there. But yeah, definitely you can see that you can see regions for improvement here. And so you can think about, well, how could I make sure that the flow is more attached there and prevent pressure losses. So that's what you're trying to fight against. All right, so that's always a very interesting one there, and it's very interesting to look at the bottom of the vehicle as well, and you can see where the flow is attached or missing. So you can see here, it's kind of attached there, but behind the wheel there, it's not attached. So this is always quite interesting for evaluating the performance of a diffuser. Is it able to keep the flow attached, or is the angle too aggressive? Um, so you could always pick up quite a nice way to evaluate stuff from that. Okay, so that's wall shear stress plots. They're very interesting. So the next type of thing I might show is, let's see, pressure, density, velocity. Oh yeah, so yeah, that seems to be it there for contour plots. There's other ones, but to be honest, that's probably some of the more interesting ones. Yes, there's a few interesting ones for turbulence, but we'll leave them for now. Okay, so vector plots, yeah, these are very interesting. Uh, so I'm going to just maybe throw in one type of these. So if we look at a vector plot, maybe along the symmetry plane. So yeah, and then auto scale the vectors. Yeah, sure, we'll see what that looks. Sure, we'll just click that and see what it looks like, and then we can adjust it depending. Okay, so that's completed there. This is what we're looking at here. So you can rescale these vectors, but it's just kind of showing you regions where the flow might be moving very quickly. So you can see the vectors are very small in there, so there isn't much flow movement. This kind of describes another way of kind of evaluating the performance of something like a diffuser. So you can see how the flow goes, and you can see most of it shoots off this way. Very little of it comes off at that angle, and very small amounts are getting pushed back down here. You can see. So you see the bit of recirculation starting to happen and starting to push this flow off. So same again, these are really cool techniques for evaluating the performance of certain aerodynamic devices. So you can see the flow starting to get much quicker here as it comes down. There's a little bit of recirculation there. So you can see that. I have a little bit of playing around with this. You can see quite a bit. So maybe one more I'll do with the vector plots is I'll try and do it along the surface of the vehicle just so you can see what that looks like. Okay, so I'll give that a look. Pause the video. Okay, so yeah, the things turned out to be pretty laggy there when I done that. So what I'd recommend if you're doing this on a full vehicle is maybe just do it on a certain part, like the bumper of the van here, or particularly I remember when I was doing this, I used to just do it on like certain parts of the trailer because I was trying to optimize that. So you can see a lot of detail, but there's a lot of vectors created here, so that's why things get quite laggy. So I'm not going to experiment too much more with this. I'll leave that to you. Right, so another thing that definitely is very interesting is path lines. I know path lines are very interesting in the wake region in particular. So I know I can use, hopefully I have trailer rear, I do, so I can hopefully try and generate some path lines coming off the trailer rear. Now I know things get quite laggy when you do create path lines. They're probably the most intense thing to create. And so we can just put them in as particle ID just so we can generally see. And steps, might leave that as 500. So yeah, we'll see what this does, and we'll come back to it. So save and display that. Okay, so this is finished here. So it always finds a bit of difficulty creating these what you call it, streamlines, because there's just so many of them that they can create of a large surface like that. But this still gives me quite a decent amount of information about how. Now this is only at a snapshot in time because this is a RAN simulation, so this isn't what it always is. This is very variable, but this just gives you an idea of what it was for that split second, how crazy the wake was, and how the lines move down from it. So you can see when these start to straighten out. You can make these longer as well by increasing your step size and your number of steps. So usually you might multiply them two numbers together to get an idea of how many meters you're coming down here. So yeah, that's the length of the streamline, you know. So definitely, if you wanted to study like a patch or something, say you had a diffuser, for example, if I just had a name selection on my diffuser, this might be more interesting because I can see the path lines coming up that, see how much of the air moves up here or just gets to go straight down the stream. So yeah, they're quite intense, and the better your computer, you'll have more chance of getting through the streamlines. Okie doke. So yeah, so they're just colored by different streamlines. You know, you could velocity color them and stuff. Yeah, so just maybe one more thing that I might look at. I just passed it there in contour lines. It's nearly finished now. Is I might create a surface. So I'm going to just display my mesh. So I'm going to go new wall. Yeah, that's what I want. Save and display that. Right, just so I can see my van and trailer again. So this should only take a second. Yeah, so that's finished there now. So there is the van trailer. Now I want to maybe go and try and create a surface. So hopefully this works. I want to create a new plane, and I want it to be an XZ plane, and I want it to be maybe, we'll say, 1 meter off the ground, and that looks just about right. Okay, so this could give me quite a bit of interesting information around the trailer. So let me close that. That's hopefully created, and then I come in here to new. And then let's say I want to see velocity as it moves around this plane. So hopefully it's here. Yeah, so that's the plane there, I believe. Turn off global range, auto range, and then we won't draw the mesh this time. We'll just have a look at it. So we'll see when that loads in. Great, so that seems to be loaded in there now. And so this gives me information looking down on top of what's going on. So usually as you move around the edge of the vehicle there, the flow will move very quickly. You can see here just the boundary layer as it starts to grow, so that's very interesting as well. So you can see, does it get much chance of reattaching? So you can see the slow moving flow close to the van, and then it gets quicker as you move off. So you have, if you wanted to use an X velocity as well, you could see a little bit better on how this flow is moving around here. And also a vector plot would be very interesting here. You'd see the recirculation a little bit better. And this kind of shows you the general size of your wake as well. So that's another one. And you can move, I think I had that 1 meter off the ground. You can make several of them, and you can get a good idea, slices of how this looks from down on top. And you can see the region in front that's affected by the presence of the van. So another really interesting way of evaluating a design is those type of plots. Right, so getting into it now. Yeah, create them. Yeah, you can create some of them, but they're not too bothered. Something that's quite interesting is a scene. Okay, so create a new scene. So this lets you turn on multiple things at a time. So I know I had my mesh on there, and I might have my most recent contour plot on there. So I'll click save and display, save and display on that. And that displays them all together, you know. So if I wanted to have a pressure plot on that and then a velocity along the symmetry, I could do that. So let's just see what this does. I don't know what that other contour plot was left as. Left as a symmetry or whatever it was left as. We'll see here, hopefully. Just give it a pause. Yeah, so it turns out that other contour plot, we left it as a wall shear stress plot, and so I had to turn off my mesh there so that we could see it. But you can see the idea there of how you can have multiple things showing. So you could have even some path lines as well there. You could turn them on, you could get a really cool image there for your thesis. You know, I've shown streamlines like this and showing pressure plots along your vehicle and some streamlines coming off the rears there. So you can get a really nice picture together doing that. Grand. Okay. So let me just close out that scene there. And I might just display the mesh there again just to kind of get that back to a normal place. Right, so what I'm going to do with you now is the final thing is just show you maybe just a basic animation that we can do. You pick up a lot of information from this. So what I'm looking for is scene animation. Is this what I'm going for? Nope. Let me just find it. Is it sweep surface? I think it's sweep surface. Just let that load up. Just get the Remember the right name on this? Yeah, sweep surface. All right. So what you want to do is, let me just get the animation. Yeah, we'll fill them in a second. So we're going to display a contour plot. Now select symmetry and let's do something like pressure. So we might look at, oh, I don't know. Will we look at, or we look at velocity. We look at velocity magnitude, right? Yeah, why not? Or no, we'll go for pressure. Right, total pressure. Cool. Yeah, so symmetry plane there. Click auto range, turn off that auto range, or sorry, turn off global range. Oh, my contour's filled. Okay, and click OK on that. So you'll see what this does now in a second. So that might take a second to load in there. You'll see how I can sweep this surface along in a second. So there's, yeah, we've seen that before. That's just a bit of a pressure plot. So I want to turn that off. Why is that still on? Let me see, is there anything? I'll just delete that scene to make sure that there is nothing coming up off that. Scene animation. Oh yeah, I know why it's doing that now. So I'll go back to sweep surface here. So this is very interesting. So I want to sweep along the x-axis plane. And if I start, so we just click play on this and see what happens. So animate. So I can judge through this. Okay, so you can see what happened there. So I want to maybe have something like 100 frames. Maybe start it from -5 and go to 15. Okay, and contours sweep along that axis. Okay, so let's animate that. So what you'll see here is as you move around the vehicle, you'll be able to pick up some information on how the flow's pressure changes. So that's an annoying plane there. That's from previously. So you can see, look at the information that I'm getting over here. As you can see, a vortex shedding off there. You can also see another one underneath. I'm actually going to just pause the video so I can get rid of this annoying thing here. So I'll be back in a second. Okay, now that I have that fixed, so we'll animate this again. So we're going to just have a look here at some of the stuff that gets created as I move this along. So this is really interesting. So the more frames you put in there, the slower you can make this happen. So you can see a vortex shedding off there. Same, there's one shedding off here. These are the usual locations. Look at how that one moves up along the top of the vehicle. So I can turn on a mesh here as well if I want to see the van as I go along, but I can see most of it here, so I'll try and keep track with it. So you can see some interesting stuff along there. You can also create vector plots for these. You can see the vector spinning as you move along. This is a very interesting way to evaluate your design. So let's see what happens. It moves into the trailer. So you can see it's kind of calming down a little bit as it moves over the top of the trailer. And it's kind of a good design there. But remember at the beginning there we said we might fix it up a little bit. So I think we're kind of moved over the trailer now. Yeah. So that's the idea. So very, very interesting plot that. So you can experiment with those being vectors and different things like velocity and stuff, but that's definitely a good way to evaluate your design. Right, so that just about finishes it up there for what you can do and what you'll want to do in terms of post-processing and a lot of the plots that you'll want to be doing. So yeah, hopefully that helps. And you can also make plots. This is a really interesting one. So data sources, and you can load a data file. So you can see here I had my lift and drag plots from, no, I didn't want to plot lift and drag in the same thing, so I'll just remove that. Okay, so I can give them a plot here, and I use these for my thesis. You can rescale them, and you can put in different types of lines. But if you have a drag report from some HPC solver that you got to write out, you can bring that back in here with load file, and you can print that out, and you can kind of see the drag coefficient that fluctuates there. You can see it kind of converge even after maybe 400 iterations. It seems to be all the same. There's still a little bit going on there. As you rescale this, you'll start to see, that that's quite a large fluctuation, and then this isn't as big. Right, okay, so that'll finish it up there. There's no point bringing up anything else. So hope you enjoyed this video. Thanks, guys.